Right, hi, this is Mrs. Lee, obviously. Uh, this is the review for the midterm. So if you notice these kinds of graphs, so basically a lot of what we did this quarter was talk about how to graph quadratics and then polynomials. Um, so a lot of the standards are going to be based off of that. So we're just gonna, hopefully this midterm will kind of help put all of the information that you've learned together, right? And then, so there are different parts of these that I'm going to be looking for based off of these standards. So FIFB4, if you look in your student view and you look at that and you're like, ooh, that one's like pretty low, then I would take a look at this. This is, determine and calculate key features. That's not exactly what it says, but that's kind of like the short version of it. Okay, so this is what I'm looking for. Can you determine like the vertex, the y-intercept, the roots? Can you figure those out? Key features, right? Is it open up or open down? The AOS, right? That's another one. Can you graph the quadratic function? Given this equation, you should know how to graph that. Factoring. So this is specifically to factoring. So if you don't factor and you use a quadratic formula instead, I won't be graphing. I won't be using that standard, right? Because that's for the basic AREIB4, which is solving quadratic equations. Can you do that in general, right? Whether it is by factoring or solving quadratic, it's usually going to be like just solving by taking the square root or quadratic formula, right? We're not really doing completing the square that much. The focus is not necessarily on there. And then factoring is more specific just to the factoring part. But then at the actual solving for X part, that's going to be down here in AREIB4. But can you just do it? Can you just factor? That would be right here. Either way you want to do that, you can, if you can factor it, go for it. If not, use quadratic formula or take the square root, depending on what the situation is. So we've done these ones right here. Take a look at this. Again, this is in standard form, and I look, okay, so there are a few things that I do need to write in here, and we did do this one in class. So I usually like to label what I'm doing. That's probably the easiest way to do it. So I would prefer, please, if you can label what you're doing as well. So my AOS is going to be purple. I think this is different in the class. And my vertex, which is very much related to the AOS, is right there. And then my vertex roots, that's what it was. I'll put roots over here because I'm going to need a little bit of room for that. And then my, what is it called? My y-intercept. So it's kind of lining all the way around here. Here's all my work. Actually, I would probably put my y-intercept not there. Maybe put my y-intercept like down here. So y-intercept, so I all have it in one area. Let's do that. So my AOS, if I take a look at this, a couple different ways to do this. I'll do it the regular standard way, and then for the next one, maybe we'll do it a different way. There's a lot of different ways. You don't have to start with just the AOS. You can start with the roots. You may want to start with the y-intercept. Probably you don't want to start with the vertex because you'll need the AOS to get to the vertex. So, but whether you do the AOS, the y-intercept, or the roots first, that's completely up to you. So AOS is going to be x is equal to negative b over 2a. So remember, it's going to be, our b is going to be right here at -2, right? This is our, let's try this again. So a is 1, b is -2, and our c obviously is 0 because it's not there. So we're going to plug these in. So remember, the negative of -2 is +2 over 2 times a, which is 2 times 1, which is 2 over 2, which is 1. All right, so x is equal to 1. So here we go. So in class, I did a more of a conceptual way of doing it. And here, this is the algebraic way of doing it. Either way is okay. So vertex, we know that the vertex is somewhere here on the AOS. And you're like, well, where is it? Well, so basically we're going to plug in 1 for x. So the f of 1. And anywhere we see an x, we're going to put in a 1. So 1 squared minus 2 times 1. Right? And then we're going to get 1 squared, which is 1. And 2 times 1, which is -2. So this is going to equal -1. If you leave your answer like that, it's wrong because that's not the vertex, right? That's just the y coordinate of the vertex. What is the vertex? 1, -1. So it has to be written as a point. A vertex is a point, so make sure it's written as a point. So here we go, 1, -1 right here. That's my vertex, just like that. And then we're going to find the roots, or maybe we'll do the y-intercept. Why not? So if you look at the y-intercept, we notice remember the y-intercept is the c. That's when, remember, x is equal to 0. So algebraically, this is literally what we're doing. So anywhere on this y-axis is where x is equal to 0. So plug in 0 for x, and we do just like how we would with vertex, with 0 for the x's. It's going to be -2 times 0, and we would get 0, right? I told you c is 0, same thing. But this is y, and so your y-intercept is just going to be 0. So right here at 0. And honestly, we actually already know the roots here. Since I know the y-intercept right here is on the x-axis, so not only is it the y-intercept, it is also the x-intercept, right? So, and I know that it's symmetrical, so technically we know where the other root is, right? Because if it's 1 away from the AOS, then it's going to be 1 away on the other side, right? So we know that it's going to be right here. I mean, right? So, but let me just show you how you would actually find that algebraically. Okay, so if you take a look at this, so remember it's x squared minus 2x is equal to 0. This is how we find our zeros, i.e. roots. And we're going to just solve for x. We can't really do that right now. If I go add 2x, then I have x on both sides. That's not very helpful. So what I'm going to do is I'm going to factor, do the GCF in this case. So I know that x goes into both of them. So I'm going to pull out an x. What do we have? X minus 2 left over is 0. Now this is factored form, right? So we're just going to split those twos up. 0 product property, which means that I can set them equal both to 0. So 0 is equal to x equal to 0, and x minus 2 is equal to 0. So if you solve for that, so x is equal to 0, nothing to solve for there. And here we would just add 2 to both sides, so all we would get is just 2. So this is the point, 0, 2, and as like we said, 0, 2. There we go, happy days, right? But that is the algebraic way of finding that. But you could, we found it because, we know a little bit about parabolas. They are symmetric. So let's go on here. Let's draw this parabola right here. So it's going through those 3 points. It is definitely open up. It crosses the y-axis and the x-axis both at 0. And it crosses the roots here at 0, 2. Our minimum, so this is opens up. It asks us that in the direction, so that's why we're writing. And this is definitely a minimum at, let's see, at -1. So the reason why we say -1, because -1 is as low as this graph is going to go. It is not ever going to go to -2, -3, -4, -1.1, right? None of those. All right, so there we go. So let's try this one right here. I'll try to keep my information the same color, hopefully. We'll see about that. We'll try this in a different way. If you like doing it this way, then go for it. You like algebraic, it's very predictable for you, go for it. It's not a big deal. But if you're like, let's see if there's a different way to do it. So there is another way to approach this problem. And that is by doing the roots first. So let's do the roots first. And honestly, y-intercept, pretty easy. It's in standard form. But let's try roots. So remember, x squared minus 12x plus 35 is equal to 0. So I'm going to first see, is this factorable, right? And so we got our x's here and 35. So it has to add up to 12. So I'm thinking 7 and 5. So here's 7 and 5. If I go x times 7, that's 7x. X times 5, which is 5x. And that does equal 12x, but I want it to equal -12. But still, when we multiply, it's going to be positive. So they both have to be negative, just like that. So which works out, because -5 times -7, positive 35. -7x minus 5x, negative 12x. So that works out. So we're going to go exactly straight across. So x minus 7. And then we're going to go x minus 5 equals 0. So remember, I'm going to just move this right over here. So we're going to just set these both equal to 0. This is our zero product property, which says that if we're multiplying two numbers, that one or the other has to be equal to 0 in order for it to equal 0, right? And then so x has to be equal to 7 and 5, right? We're adding 7 to both sides, get 7. Add 5 to both sides, get 5. So here we go. So there are my roots right here, 7 and 5. So there's my roots. Now, my AOS, this is where I can figure out my AOS because I know that, remember, it's symmetrical, right? So if my roots are at 5 and 7, where's my AOS? Right there in the middle, right? So it has to be here at 6. Oh, I probably should not do this in green because that will be confusing. I do it in purple. Keep the same color. So here's my AOS. I dot it because this is technically not part of the line. This is just my guideline. So my AOS is x is equal to 6. Do I need to show the work for that? No, because I just visually see it, right? If you want to do what we did over here with the AOS, please do that. It's a good practice, right? But you don't have to do that, especially when you know the roots, right? If you know the roots and they're really nice, easy numbers like these integers, yes. But if they're like using square roots, then I'd go use the AOS formula, which is over here, the x equal to negative b over 2a. I'd do that. All right, so now we know our vertex is going to be somewhere on this AOS. Where exactly? I don't know. I have an idea, but we're not going to get into that. So this is going to be f of 6, right? Whatever our AOS is, because we know that that is the value of our x. We're just going to put in for all the values of x. So 6 squared minus 12 times 6 plus 35. And you could just put it into your calculator or do it like this, the longhand way. Just make sure you don't make any mistakes. And this is going to be 71. 71 minus 72 is going to be negative 1. So my vertex, remember we write this as a point, so it's going to be 6, negative 1. That's my vertex right there. We're going to go over to 6, which is exactly where it should be, and then down 1. That's our vertex right there. Yay! All right, so now we can see, oh, it looks, we can kind of know what the shape is going to look like. Don't forget our y-intercept. Y-intercept is just going to be this guy right here, y, because when x is equal to 0, those become 0, and all we have left is 35. So it's going to be 35. If we want to be a little bit more, detailed. So it's going to be way the heck up there. So technically, this doesn't make it to the show. All we're showing is this part. It is way too high. So now we're going to draw a graph. We're going to go something like this. Try to make them so that the arrows kind of point a little bit outwards. It shouldn't be straight up and down. If it's straight up and down, that's no longer a function, right? So it should be slightly tilted, but not too much. All right. And so this again is open up. And also there is a minimum at negative 1, because that is how low it goes. Oh, which is the same as that one. Who knew? All right. So again, I would try these out if I were you. You're gonna have to see these equations in many different forms. Remember, at the end of the what is it called? The packet, there are answers, so that will help you out. We'll go from there. I'm gonna do another one. Let's do number 4. Right, number 3, I'll leave for you to do and just check the answers. Right, but let's go right here. So here is our AOS. Again, our vertex. And our roots. And then our y-intercept. All right, so now, which one do you want to do first? I kind of want to see if I can factor this, so I'll do that. I like the visual, like the see if it makes sense way. So negative x squared plus 2x minus 1 is equal to 0. And what I like to do here is I actually like to make sure that the a is not equal to negative numbers, just because it's a little bit easier that way. I like to deal with them when they're positive instead of negative. So what I'm going to do is I'm actually going to multiply this by negative 1. Multiply both sides by negative 1. And if I do that, I'm not changing the value. I'm just changing the way it looks. Right? Because then what do we get? It's going to be x squared minus 2x plus 1 is equal to what? 0. This is the power of 0. I can literally multiply this by whatever I want to multiply it by, and the right-hand side will still be 0, as long as I'm multiplying or dividing, right? If I am adding or subtracting, that this is no longer going to be 0, right? But if I'm multiplying anything I want to, it'll still be 0. It's the happy day, right? Now this is a little easier for me to factor, but honestly, if you factored it like this, you could have. You just have to make sure one of those is negative. That's all. Only option for me here is this 1 and 1. I know that they both have to be negative because I know it adds up to a -2. But they both have to be negative just like that. And then we get x minus 1. Oops. Just kidding. It's giving -1x and -1x. These two right here. That gives me a -2x. So we're good to go. So this is going to be -1 to x minus 1. And then we have 2 of those, and it's equal to 0. Well, we know how to deal with that, right? So this is going to be x minus 1 is equal to 0. X minus 1 equals to 0. So we get literally just one number, just a 1. And guess what? It came out 2 times. So technically we should write down multiplicity of 2 now that we know better, right? It's the 1 multiplicity of 2, right? It's a double root, right? Which means what? On the x-axis at 1, it's a double root. So it's gonna bounce up and down. That's it. It's not gonna go all the way through. It's just gonna phew. All right, in which case, okay, well, now we know where the AOS is, because if this is the double root, we've actually solved a lot of different things here. If it never crosses that again, well, we know that the AOS is right here, right? AOS is right here at 1. X is equal to 1. Then where's my vertex? Remember, the vertex is on the AOS. So actually, that's our vertex as well. So this point right here is doing a lot. It's the roots. It's where the AOS is, and it's where the vertex is. And so this is going to be exactly right there, just like that. So now that doesn't help us create the shape. Is it going to be open up or open down? So if you take a look at this number right here, remember the A? Yeah. So that's negative, which means that we're definitely going to be opening down. So we know it looks open down. But we also know y-intercept is going to be here at -1. So down here at -1, which means we know the other point, because remember, symmetrical. What you see on one side, you see on the other side. Right there. I see symmetrical points. Do you? All right. So here we go. So it opens down, and this is going to look something like this. All right. So that's going to be right here. And what is our max? How high does it go? Remember, we're not saying, oh, it's at 1. No, how high did it go? So it's a max at where? At 0. Remember, you're looking at the y value, right? The y, how high does the y at? And it's right here at 0. That's 0. Not at 1, because that's where the x is at. Different. Okay, so there we go. Max is at 0. All right. If we had a kid who's in class, we'd be like, oh, max is at 0. All right. Now, what if it was in vertex form? What would we do? Same thing, right? Treat it exactly the same way. Nothing is different. Just we have to do a few things a little bit differently, but it's the same process. It's the same idea. So here we have AOS. Here we have vertex, just like how we've been doing this whole time. We have the roots right here. And then we have the y-intercept. Okay, so now, okay, remember this is vertex form. If this is vertex form, what does it tell us? And the way you can recognize that is if you have parentheses with a square right there, and then this number on the outside, okay? So it kind of looks like standard form, but also kind of looks like factored form. When it does that, okay, that's definitely factored vertex form, okay? So now vertex is right here, these two guys right here. So this is going to be 2 and -1 right here, just like that. So 2, -1. And remember, if you remember the vertex form, if you've written it down somewhere, it normally looks like this. So if f of x is equal to a times x minus h squared plus k. So if you notice, the h in front of the h is a minus, so that's why it's naturally support. Like if you remember us doing completing the square, this was already a minus, so that's why the h is just the h by itself, and we assume that that's going to be a minus there. So then the question is, well, then what if it's a plus? Then what do you do, right? So remember, the only way, if this was, let's say, a plus, oops, didn't mean that. If this was a plus, so it's x plus 2, the only way it became a plus 2 is if the vertex x part was a minus and negative 2, right? Because minus and negative is the same thing as plus. Hopefully I didn't confuse it too much. But regardless of which, we're going to move on, because we'll probably see something like that in the near future. All right, so our vertex is right here at 2, -1. Notice we did not do any calculations because it's already given to us. All right, so there it goes. There is the vertex right there, which we know the AOS lives there too. So we're going to draw in the AOS right here on the vertex. So that is going to be right here, x is equal to 2. So far, so good. So now, a lot of people think that the y-intercept is this -1, because that's what it was for the, what is it called, for the standard form. Not the case, because remember, for standard form, when we plugged in 0 for, if you look right over here, when we plugged in 0 for x, we got that last number right here. So if you plug in 0 for x right here, these two would become 0, but then we still have this plus 35 there, right? In the vertex form, if we plug in the 0 in for x, 0 minus 2 is not 0, it's -2. So that no longer applies to this case. Okay, so we're gonna, since we've been talking about it, let's talk about the y-intercept. So we're going to figure out what is y when x is equal to 0. So f of 0. So -1/2 times 0 minus 2 squared minus 1. All right, so what are we going to do from here? Order of operations, or plug it into your calculator. So 0 minus 2 is -2. And so -2 squared is 4. So let me just write this out. -2 squared. So -2 squared is 4 times that by -1/2 minus 1. All right, so now we have to multiply before we do subtract, right, PEMDAS? I don't like saying that, but order of operations is what I'm going to say. So 1/2 of 4 is 2. So, and don't forget that's negative, so it's going to be -2 minus 1, which is -3. So -3, so here we have to do more calculation to get our y-intercept. So our y-intercept is here at -3, which is kind of to be expected because remember, this is our a right here, and our a is negative, which means it opens down, right? So yeah, this kind of looks like it would open down. And remember, we have our symmetric point, right? If this is 2 away from the AOS, then we have to go on the other side 2 away, and that's our symmetric point. All right. And let's take a look at our roots here. Because if you're like, okay, well, it's never going to cross the x-axis at this point, right? You're not wrong. So we are expecting to have negative or to have imaginary roots here. And if we don't get imaginary roots, then we did something wrong. Somewhere we went wrong. So let's try this out. So we're going to just set this equal to 0. So it's like how we normally would when we're finding our roots. All right, and then we're going to add 1 to both sides. Oops, wrong one. And then we're going to have -1/2. I know that -1/2, you're like, no, I don't want to do it. It's not bad, I promise. So it's equal to 1. So how do we get rid of a -1/2? The best thing to do is just to multiply it by its reciprocal. Or what a who? Multiply it by when you flip it, reciprocal, right? And so instead of being -1/2, it's just going to be -2/1. And this has to be negative because when we go negative times negative, it'll cancel out that negative, right? It makes that become positive. So I'm just gonna, or you could have just said -2 instead of -2/1. Same thing. Okay, and then what do you get? X minus 2 squared, and then 1 times -2, which is -2. Now, we're going to, how to get rid of that square? How do you get rid of any square? Square root them. All right, and then we are almost there. So I'm just going to draw an arrow like this. So here we get x minus 2 is equal to plus or minus. Don't forget, did you forget the plus or minus? I hope not. But if you did. So remember what the square root of negative 2 is. Whenever we have a negative inside the square root, that means we're in the world of imaginary numbers, right? So this one actually should be written a little bit different. I'll rewrite it after we do this adding 2 here. Okay, and so we're going to get x is equal to 2 plus or minus. Now remember that negative means that we're dealing with imaginary numbers. Once I write that I don't need to put a negative in there anymore because I've already indicated, yep, we dealt with the negative number in there. So square root of negative 2 or square root of 2. All right. Right, so now that we have the roots and we know that they're imaginary, so that means it will not cross the x-axis. Let's try this out. We're going to just graph this. Got the 3 points like that. Don't really need more than 3. There we go. Yep, and as you can see right here, it does open down. Crosses the y-axis at -2. Haha, just kidding, -3. Vertex is right here at 2, -1. And AOS is here at 2. Does not cross the x-axis ever, which is good. This is what we were hoping for because this is our roots right here. So again, if it happens to be that your roots on the test come out to be imaginary, don't stop. You just keep on going because I'm still looking for this. Can you solve this, right? And this is you solving it. Okay, so make sure you do that. All right, there we go. Let's try another one. We're gonna do one like number 6 in a bit. So let's try one more vertex one, vertex form one. Although I should say technically this is in vertex form, right? It's just if we write it like this and you're like, no, that's standard form. I'm like, no, it could be vertex. It could be both. So if you write this as 2 parentheses x minus 0 squared minus 1, right? Because what's x minus 0? X squared. So yeah, vertex 0, -1. Easy, just like that. You don't even have to do any calculations. All right, so let's try number 8. So if you look at number 8, let me do the AOS and all that kind of stuff here. So AOS, vertex, we have our roots, and we have our y-intercept. And if you're like, Miss Lee, I was doing number 7, I really don't understand, or number 6, then just ask me, send me an email and I will write them out and then send it to you. But if not, it's not happening. I would take a look at the answers at the bottom of the page and you can figure that out. Right. So here it is. Our AOS is going to be, again, pause, do it yourself, and then press play. It's the best way to learn. So AOS, we don't need the AOS just yet. Actually, we know what the AOS is. It's right here. It's the X part right here, which is 3. So X equal to 3. So here it is, right here, boom. AOS. Happy days. Vertex is going to be, if our X part is 3, that means our Y is right here at -5. Okay, remember that this was supposed to be a minus, so that means our number for X is just 3. So 3, -5, it's going to be right here, -5. Perfect. Now our roots, we'll do our roots first this time. I normally like doing the y-intercept last. That's just me though. So remember, we're setting this up. Squared minus 5 is equal to 0, right? And then so what we're going to do is we're going to add 5 to both sides. So we're going to get x minus 3 squared is equal to 5. And then we got to get rid of that square root, right? So we're going to square root both sides. So x minus 3 is equal to plus or minus square root of 5. Okay, and then from here, how do we get rid of this minus 3? We got to add 3. So x equal to 3 plus or minus square root of 5. Right. If you notice, I didn't put in those other little extra steps in there, and that's okay. But if you want to, go for it. Okay, you will lose nothing by going for that. Okay, so, and what does this mean? 3 plus square root of 5. Like, what does that mean in, like, when we graph it? Like, I don't know what that is. So this is what we can do. Let's go here. So if you notice right here, our 3, that's our AOS, right? So we're literally on the AOS, we're going to go to the right square root of 5 and to the left square root of 5. The question is, what is that square root of 5? So if we just go square root of 5, technically, right? I mean, you don't get it like, so you would go 2.2 to the right and 2.2 to the left. So we could say, so 1, 2.2, 2 to the right, and then 1, 2.2 to the left, right? See, there's my roots right there. That's what that means. But if you're like, Miss Lee, I like actually want like numbers, then I'm like, okay, fine, because we got to solve a thing. So here we go. Oh, I can't do both at the same time, apparently. So here we go. So we're going to go 3 plus square root of 5, enter. So 5.2 about. We don't need to get much more exact than that just because we're actually plotting a point and we're not going to be that exact where we need hundredths place. So 5.2, so notice right here, that is 5.2. See, told you, right? And then we're going to go 3 minus, oh, nope, just kidding. Go back. So square root of 5 is going to give me about 0.8, right? So again, 0.8 right there, see? Same thing, like I said. Okay, so it was 0.8 and 5.2-ish, okay? So again, like I said, 2.2 to the right, 2.2 to the left. And there we go. So we know our roots, our y-intercept. So we know it's going to look up like this. So we're expecting that our y-intercept is going to be positive somewhere. Maybe like, it's not going to be at 0. It's maybe 1 or 2 or 3. So let's find out. So y-intercept is when x is equal to 0. We were f of x. So f of 0 is equal to 0 minus 3 squared minus 5. So we're going to just order of operations. And that's going to be -3 squared minus 5. So this is going to equal 9, not -9, because -3 times -3. And then minus 5, which is going to be 4. So our y-intercept is 0, 4. 0, 4, there we go, right there. And remember, that always gives me gives us our symmetrical point there. So it's 3 away from the AOS. So we're going to go 3 on the other side for the AOS. Do you have to do it? Not really, but it is. I like to be exact, right? So as exact as you get a much better parabola this way. And I would hope that all the engineers are like me, where they want to be exact, right? Because if they don't, that's like sad days, We don't want that. There we go. Don't make sure you put in the arrows. All right, so that's how you how you graph a parabola with it in vertex form. All right, we're moving on. We're going to go, here is factored form, if you are ready. So here we go. If it's in factor form, again, same thing. We have our AOS. I feel like I've been doing this for like ages. Vertex, our roots, and our y-intercept. Okay, so let's take a look at this. Always for factored form, what I would like to do first is do the roots. That's what you start with because that's what it gives you the first. Just like on here for vertex form, since it's the vertex form, you can start with the AOS or the vertex because it refers to both, right? Or to start with the vertex. That's fine because that's the vertex. So factored form, always start with the roots. So again, we're going to just set these equal to 0. So 1/2 x minus 2 times x plus 6 equals 0. And now that since it equals 0, then why does it equal 0? Because that's where it is on the y-axis, it's 0, right? So on this x-axis, the y is equal to 0. That's why we say y is equal to 0. All right. So knowing this, we know that x minus 2 has to equal 0 and or x plus 6 is equal to 0. That's going to give us a 0 for the answer. So if either of these are true, That's what's going to happen. So x equal to 2 and negative 6. Now you may wonder, well, what about the 1/2? It doesn't matter, because if this is 2, if x is 2, 2 minus 2 is 0, right? What's 0 times 1/2? 0. 0 times whatever that would be is like 8. It'll still be 0. So it doesn't matter. This 1/2 is irrelevant. It doesn't help us with roots. Okay, that just helps us with the shape. So here are my roots at 2 and negative 6, just like that. Now, what I like to do here is, so you could either do the AOS or the y-intercept, but I like to do the AOS. I like to leave the y-intercept for last. It's kind of like my way to check to see if I did it right. So AOS, remember, it's halfway in between, so it's kind of farther away. So I'll show you an algebraic way of doing this, but you could go 1, 2, 3, 4, 5. Oh, that's too far, because that's 3 on this side, so about 4. So right here. So this is going to be, my AOS is at negative 2, right? You just kind of like put your fingers and go in and find the middle, right? Kind of like how you find the median. Same idea, right? But what we're going to do here is just going to find the average. So if this is a little bit unclear, you're like, okay, so 6, so x is equal to 6 plus 2 divided by 2. You're literally just finding the average. So average of the roots. So it's going to be negative 6 plus 2, which is negative 4 divided by 2, which is negative 2, just like what we said. So x equals to negative 2. So that is the average, the algebraic way of doing it. So let's see here. Okay, so now we know that the vertex is somewhere on this purple line right here. So we're going to plug in 2 for x. So we're going to go f of 2 is equal to, so oh, don't forget the 1/2 on the outside there. That is important. And then we got 2 minus 2. Ooh, 2 minus 2. I think I already know the answer. Oh, wait, it's not 2, it's negative. Oops, sorry. See, do you see how that makes it? It's just a negative, but it makes a huge difference. Okay, I'm kind of going into that one, so apologies for that. So we got 1/2, and then negative 2 minus 2, that's negative 4. And negative 2 plus 6 is going to be positive 4. So I know my whole answer is going to be negative because I only have one negative here. And I have half of 4, which is 2. And then 2 times 4, which is 8. So my vertex is going to be 2 and negative 8. So here's 2, negative 8. Oh, right down here. Okay, it looks like it's going to be going up like this. I'm expecting my y-intercept to be around either 6, negative 6, negative 5. If I see it as a positive number, then I know I did something wrong, because that doesn't make any sense. So here's my check for the y-intercept. This is when x is equal to 0, right? So f of 0. So 1/2 times 0 minus 2 times 0, that's a 0 plus 6. And that's going to be 1/2 times negative 2 times 6. So half of 2 is going to be 1. So this is going to be negative 6. Just how we thought. There's negative 6 right here. So which means the symmetrical point is 2 away from on the other side. And there we go. And we're going to make a nice round bottom all the way up. Okay, this isn't terrible. Do you see how the points help you? All right, so it kind of like checkpoints, right? So that's going to be our parabola, right? All the information opens up. Our minimum is going to be at negative 8. There we go. Right, that's how you find it for those ones. Let's try it for number 10, maybe number 11 or number 12. Which one? Let's do number 12. Let's just do number 12. I have a little more room there. All right, I don't really have room for the other ones. I wonder, are you still with me? Are you still there? I don't know if anybody gets to this part, but this is maybe just for me, I guess. Okay, so again, we're going to do AOS. And you'll see a lot of these ideas repeat again and again. And this, like how we get like the vertex, or how you would get, let's see, the y-intercepts or the x-intercepts, it's the same for any polynomial, right? It's just, it's a little bit easier with a quadratic, because how are you going to factor something to the 5th power? You can, right? If it's factorable, you can, It's just harder, right? It's just not as easy. So, but the same principles apply. So AOS, we have our vertex, we have our roots. What else do we have? We have our y-intercept. All right, so let's take a look here. Again, since this is vertex, I don't know why I'm so squished in here, right? When I have all this room. So let me make myself some room. So here's my roots over here, and here's my y-intercept over here. See, a lot better. Okay. So again, I'm going to start with my roots. Oh, I changed the color on it. Didn't want that. Okay, there we go. So we're setting this equal to 0. So x plus 6 times x plus 5. Please make sure you show this step. Really important to you that you know, and that I know that you know, that this is supposed to be equal to 0. And then we're setting both of these equal to 0 because of the zero product property. If you don't remember what that is, look it up. All right, Google knows. So x equal to, remember, we're going to be subtracting 6 on both sides, so that will be -6. Subtract 5 on both sides, so -5. All right, so those are my roots at -6 and -5. Ooh, this is going to be interesting. Now, where would be the AOS be? Halfway in between, right? This is going to be interesting. So our AOS is going to be actually a decimal or a fraction, whichever one you want to do. I think it's easier to write decimals in your calculator than fractions. So our AOS is going to equal -5.5, right? You see it's between -5 and -6, so -5.5, which means our vertex, ooh, we're going to have to do some calculations. So f of -5.5 is equal to, so it's going to be, oh, I don't think it's going to be too bad, -5.5 plus 6, and then -5.5 plus 5. And so I know that this is going to be 0.5, and this is going to be, so times by -0.5, right? And then 5 times 5 is 25. So this is going to be -0.25. It's -1/4. Okay, so it's going to, okay, this is going to be tiny. So it's going to be a -1/4. So it's going to be like right below there. It's not at the x-axis. It's below it. It's a quarter below. All right. So our vertex is going to be at -5.5 and -1/4. All right. So if you zoom in, let's see if I can zoom in. If you zoom in, do you see right there? It's not at the x-axis. It's a little bit below, right? And then so I'm expecting that, since this looks like it's going to be pretty narrow, I'm expecting that it's not going to hit any of these and it's going to be pretty high, but we'll see. So let me zoom out just a little bit here. Oh, we got almost everything. We're just going to get the y-intercept. And this is, I'm thinking that is not going to even hit that y-axis. It's going to be above 8. Let's find out. So again, this is going to be when it's going to be f of 0. It's going to be 0 plus 6. And some of you guys with good predictive skills are like, oh yeah, it is, right? Because what is 0 plus 6? 6. 6 times 5. So we know that this is going to be 30, right? Yeah, so it's way the heck up there. So, but we still have 3 points, so we can still graph this. Just make sure that you're not doing one of these guys. So I've seen this before. I've seen this. And what did I just do? I just made the y-intercept be like 7.8, right? That's not right. It should definitely not go up that like that. So when you're graphing this, just make sure that it doesn't look like, so it's still tilted. So going through all those 3 points, but it's not going to cross the y. If I were to continue this line, it doesn't look like, oh, it's a terrible line. If I continue this line, it doesn't look like it's going to cross anytime soon until you get up to 30, like way up there. Okay, so there we go. Look at all of them. Again, it opens up. And this is definitely a min. What is the min at? -0.25. That is how low it goes. -1/4. It doesn't go any lower than that. That's all they got. Okay. All right. So what about something like this? I said we were going to go over something that looks like this. So we'll go over 2 of them. And then you can do the rest. So we'll do one with a fraction. We'll do one without that. So we'll do number 13. Do number 13 and then number 14. I think that's good because we get one of each If you don't know what I'm talking about, then it's okay, because you'll soon find out. So here you go, AOS, vertex, and what is it called? Roots. Get back to my roots, and our y-intercept. All right, so our AOS, okay, actually, we can do this one of two ways. Remember, this is the vertex formula, or should we go with the roots? Let's go with roots. Okay, let's go with the roots. So remember, we're going to just set this equal to 0. Notice we only have one x, which means we could just solve for it. Like, there's no problems now. Like, we don't have to factor, we don't have to like do anything. It's just solve for x. So we add 2 to both sides, right? So we're going to be like plus 2 plus 2. And then what do we get? We get, I'm going to just write down over here, x squared is equal to 2. Well, how do we get rid of the square? The same way we get over any square. Square root them. So x is equal to, did you do it? Did you write it? Did you write square root of 2? If you did, you're not all the way there. What did you forget? Plus or minus. Hopefully you were saying the plus or minus, right? So that's what that's going to be. So our roots are going to be plus square root of 2 and then minus square root of 2. Notice we don't actually have any thing we're adding it to. It's just 0. So which should give you an indication of something. But here it is square root of 2. Square root of 2, here we go, it is 1.4-ish. But all we need is about 1.4. So this is about 1 plus or minus 1.4. So we're going to go 1.4 to the left, or to the right, and 1.4 to the left, which means where's our AOS? Right? If this 1.4 to the left and 1.4 to the right, our AOS is right straight down the middle. Ooh. Right? Because it should be symmetric. Right? Even if I moved a little bit to the right, that's not symmetrical anymore. Right? So our AOS is x equals to 0. Right? And if you wanted the algebraic version of that, so remember our A is equal to 1, our B is equal to not -2, because that's what our C is. We don't have a B, which means that's just 0. So remember, it's going to be x is equal to -b, which is 0, over 2 times 1. So again, see, 0, right? So our AOS is 0, which means our vertex is somewhere on here. Where is it? So let's just plug it in. So f of 0 is going to be, and again, we find this. This is very much like our y-intercept, right? Actually, it's exactly the same. So here we go. This is going to be 0 squared minus 2. Well, you know what that is? It's just 0. So all we have left is -2. So again, vertex is a point. So it's going to be 0, -2. There we go. So 0, -2. Just like that. Looks like it opens up, which makes sense because our A is positive. So it should open up. And our y-intercept, we would do the exact same thing, right? So all this here, same thing. So our y-intercept is also, so that at 0, -2 is doing two things. It's being the vertex and the y-intercept, both of those guys. All right, and we're gonna just graph this, because if we have at least 3 points, we're good to go. Boom, and just like this. And some of you guys may be wondering, well, what if we have like only 1 point on the line? Then what do we do? Honestly, on the test, there won't be any problems like that. But if there was, or maybe there was because I made a mistake, it's possible, right? Then just pick an X, like how we just plug in a point right here, pick an X, right? So if you're like, okay, don't pick it like a big X, because if you pick a big X like 10, then first of all, we don't even have that on the graph here. And plus, since we're squaring things, it's going to be really, really big, so, or really, really small, depending, right? So it's just not worth it, right? So you're just wasting time. So if that happened, right? Like, oh wait, I only have 1 point. My vertex is the y-intercept, which is also the root. Like, what do I do, right? Then just pick another point. Like, so pick an X, like any X, small X. That would be like, okay, well, let me figure out when X is equal to 1, right? And I'll just use this problem right here. So that would be 1 squared minus 2, just like how we've been doing, right? And this is going to be, well, 1 squared is 1 minus 2. So that's going to be -1. So when X equal to 1, Y is equal to -1. We're like, oh, right here. Oh, I was actually pretty close with that. So remember, and it has, once you get 1 point, you can get the other point, as long as it's not the vertex. which this is not. So that means it's also this point right here. Oh, look, see, I did actually a pretty good job of trying this. So that would be my 2 other points in case if I didn't have the roots like that. Or you just didn't have 3 points. This is right. There we go. So, and I said we would do one more. So this is the last problem, unless you're going to do more problems, but I'm not going to do more problems unless you want me to. But again, email me. Okay, so our very last one together. Don't cry. It's okay. We will survive. Barely, but we will survive. Vertex, and here we go. And we have our roots. I'm going to have roots like right over here, and my y-intercept over here. So again, I'm going to just go with, well, honestly, I know my y-intercept right here, right? It's pretty easy. It's just this plus 5, because again, this is in standard form. If you want to call it vertex form, that's fine too. But this is the only time where this plus 5 in a vertex form is going to work, because your x part is 0. So if you plug in a 0 here, it's 0. Only time it'll work. And okay, so our y-intercept is at 5, so we can graph this right here. I can't graph the symmetrical point because I don't know where the AOS is yet. So therefore, we'll do that later. But there's my y-intercept right there, and I'm going to go with my roots. Start with my roots. And we're going to just set this equal to 0. Okay, and we're going to subtract 5 on both sides. So that's going to be -1/3 x squared is equal to -5. And nope, actually this didn't work out according to plan, but that's okay. Remember I said, oh, these are different. I forgot that this one was negative, so that's okay. So we're going to just multiply. Remember how I said to get rid of these fractions? Just multiply by the reciprocal. So that's going to be -3/1, or we can just say -3, right? Same thing. And we're going to get just x squared on the left-hand side, and -5 times -3 is 15. So how do you get rid of that square? Square root it. So x equal to plus or minus square root of 15. What in the world is that? Well, I don't know where the square root of 15 is either. So we're going to take a look at our calculator and go square root of 13, square root of 15, and about 3.9. Okay, so this is right before 3, right before 4. So it's going to be plus or minus 3.9. All right, so we're going to go 3.9 to the right. So here's 3.9. So it's a little bit before the 4. And again, a little bit before the -4. And notice, you see how it's going to go down like this? And honestly, it kind of looks like our vertex is going to be our y-intercept, right? We'll find out. Okay, so how do we find the vertex? Well, yeah, how do we find the vertex? Actually, we need to find the AOS first, right? So the AOS is when x is equal to 0, right? Actually, what is the AOS? We can find this out. Okay, so remember, we know where the roots is, right? Where the roots are. So remember we went, what is it? 0.39 to the right and to the left, which means it has to be right here at 0. There's no choice. Which means this is the vertex, because honestly, there cannot be 2 points on the y-axis, right? So we cannot have one be the vertex and one be the AOS, right? One be the y-intercept, right? That's not possible. Then it's not a function. That defies all rules of being a function, right? So if you have a point on there already as your y-intercept, and that's where your AOS is, that means that's your vertex. Okay, so our AOS is going to be, what is it called? X equals 0. There we go. I forgot for a moment. I was like, what am I doing? Where am I? And if you wanted to use like what we did for factored form, we could just take our roots plus or minus square root of 15, and then just find the AOS that way. So if you're going to go, oh, because you can take our roots plus 15, square root of 15 minus, or I should say, come on, plus square root of 15 plus negative square root of 15, right? Divide that by 2, and you still get 0, because square root of 15 plus negative square root of 15 becomes 0. All right, so now our vertex. We're just going to plug this in. f of 0 is equal to, and honestly, do you really need to write this out? I mean, no, not really, because you can kind of see here, well, that means this is going to be 0 squared. What's 0 squared? 0. 0 times negative 1/3, 0, which means all we have left is 5. So this is going to be 0, 5, which is, you know, what we said it was going to be. So there we go. So our graph is going to go like this. We got 3 points. We're happy. So, and if you notice right here, we could not find a symmetrical point for the y-intercept, but because it is its own symmetrical point, it's already on the y-intercept, the y-axis, which is the line of reflection. Okay. So there we go. That's our answers. All right. So hopefully this is helpful for you. Again, if you have a few more questions, you're like, Miss Lee, I don't understand this one part here, please let me know and I'll get back to you. Unless you're watching this 5 years later, in which case I don't know. All right. Have a good one.